everyone, and welcome to the last lesson of Activity 28, Lesson 28.3. Today we are going to start by reviewing a little bit of what we talked about last lesson in 28.2. We are also going to talk about beginning to sketch our polar curves on a polar grid. Now, the last lesson, 28.2, talked about converting between polar and rectangular, and then vice versa. So we start the lesson on page 386, kind of reviewing that same fact and talking about how we use basically two things to convert from x comma y to r comma theta. And the first thing being Pythagorean theorem, because we know r squared is going to equal x squared plus y squared in the right triangle that we just drew in here on this picture, which if we square root, r is going to be the square root of x squared plus y squared. Okay. Now to get our tangent value, or excuse me, our theta value, we have to use tangent because again, x and y are the opposite and the adjacent. So tangent of theta is going to equal y over x, or tan inverse is going to be how we would find that, again, of y over x, that fractional value. Now, again, we chatted in the last lesson how it's really important to think about what quadrant you're in, because when you take tan inverse in your calculator, it's not going to necessarily give you the answers for quadrants 2 or 3. You're going to have to make sure you make them between the appropriate values. And again, this picture, it just probably feels like it never goes away. We've been talking about it since literally Unit 3. You want to make sure you really think about what quadrant am I in my rectangular coordinates, because that's going to affect my theta value. For instance, in the example they have here, if you're at negative 9 comma 9 square root 3, you're in quadrant 2. So you're right here, which means if you're taking tan inverse in your calculator, you're gonna have to be careful of your theta value. Because you're squaring the negative values, that's not going to affect things for the r value, but the tangents where you have to be careful, because otherwise if we take tan inverse of y divided by x, we would get negative 60, which we know is over here in quadrant 4 area. So we would have to add 180 to it to make sure we're using the quadrant 2 value. So again, you want to think about making sure you're in the appropriate place. And we also talked about some other examples, including checking some of your answers when it comes to the calculator. So we did talk about how you can use your graphing calculator to double check this, and that is using the second apps menu. So you're in the angle menu, and options 5 and 6 will convert from rectangular to your r and from rectangular to your theta. And to do that, you would type option 5 and then x comma y, and we see we get the 18 for the r value. And then we also can do second apps option 6 to convert to the theta, and again negative 9 comma 9 squared root 3, and we get that final answer of 120. Okay, so this is a really nice option because these buttons do take into consideration their theta value here, what quadrant you are in, so it's a good way to double check yourself. Now, a lot of times too, just as a side note, especially the quadrant 4 values, so if we kind of look up on page 387, be aware that when you're in quadrant 4, so for example with letter B, a lot of times you're going to see your answer expressed two different ways. You might see it as like the negative theta value. You also want to consider a lot of times they're limiting these to be between 0 and 360. So just be aware that we've talked about it before, but your polar coordinates again have a lot of values that are the same location on your polar grid. Now, moving forward on page 388, if you look at number 4, they are asking us to graph on our polar grid the values for 6 cosine theta for the values from 0 to 90. So to kind of, you could type all this in, but just to kind of teach you some graphing technique with your calculator, if you type into the y equals menu, you will have 6 cosine m of x. And then I want you to hit second window to get to your table set menu and start your table at 0, and then make sure the independent variable is selected to ask. Because what this is going to let us do is when we have second graph to get to our table menu, we can type in 0, 30, 60, and 90 and get those approximations for our table rather quickly to be able to graph. So we have 6, 5.2, 3, and 0 that we want to make sure we graph. So again, 0, 30 degrees, 60 degrees, 90 degrees. We're at 1, 2, 3, 4, 5, 6, and then 5.2, and then 3, and then 0. So when we connect these, what we start to see is that this looks like a semicircle so far, right? It kind of has that curved appeal like a semicircle. And if we keep going all the way to 180 on this table, so we have not 210, 120, 50, 180, we see actually we're at the negative value, which remember if we add 180 to each of these values, we get back to that positive value. So what we'll see is we'll be back here at 0, and then back out to 3, out to 5 point, and then back to 0. So we see the continuation on then of our full circle. So we're noticing kind of this pattern between circles so far and this r cosine theta look. And what we can do is we can, instead of just relying on the graphing, we can start converting between the polar equation into a rectangular equation so we can see for positive what is going on here between these two. So notice from what we've talked about before, 3 formulas you are definitely going to want to write down. Okay. We've talked about how r equals the square root of our x squared plus y squared. Now, if we rewrite cosine as x over r, right, adjacent over hypotenuse, that would be x over the r value that we just substituted in. And then same thing with sine, but you're using your y value. Definitely something you want to have written down. Now, when we make that substitution in, r cosine theta, substitute in for cosine theta, substitute in for r. When you multiply both sides by the square root of x squared plus y squared, the square roots end up canceling out. And then if you subtract the 6x over and complete the square, what we end up noticing is this is the equation for a circle centered at 3, 0, which, if we look back at our last picture, makes a lot of sense. That looks like a circle centered at 3, 0. So we see that connection. Okay. So let's try another example for this one. If we look down here at r sine theta, again, when we complete the graph here, we're going to want to type in for sine of theta. And as we look, not that graph, we want to look at the table. So second, and then table, to look at our pieces here. We're at 0, and then we're at 2, 3.5, and 4. And then, 2, 3.5, and 4. And then we follow back around to 3.520. So we have this little circle here. Okay. Now to transform this into a rectangular equation, we're going to take our r and our sine, and we're going to make that substitution in. So we have square root of x squared plus y squared equals 4 times the value of y over r, which again is x squared plus y squared. Okay, again, making sure we have these equations written down to make that useful substitution. Now, when we multiply both sides by the square root of x squared plus y squared, cancels on this side, and then anytime you multiply a square root by itself, the square roots cancel, and we're just left with x squared plus y squared equals 4y. Okay? Bring everything over to one side, just like we did with circles in the conics unit. We're going to have to complete the square currently on our y values. So divide -4 by 2 and square that value. We add 4 to both sides. And then last but not least, x squared plus y minus 2 squared equals 4. So we have a circle centered at 0, 2 with a radius equal to 4, and, oh, excuse me, not 4, square root of 4, which is 2. Which makes sense when we look at our picture. It looks like we're at 0, 2 is our center, radius of 2 all around. Makes a lot of sense on that. So there's our example with the circle. Okay. Now, we will definitely work more with both the converting between the forms and the graphing in class. Please make sure that you have these equations written down. And congrats on finishing activity 28.